Welcome again to this course about ethical hacking with kernel Unix from beginner to advanced. We'll explain now the OZ model, the IP addresses and the MAC addresses, the difference between each layer and everything related to the OZ model. In fact, what is the OZ model? The OZ model is constructed with 7 layers: the physical layers, data cables, and the second layer, data layer, which contains switching and MAC addresses. Third layer is network layer, which contains IP addresses and routing. The transport layer, which contains the TCP and UDP protocols. And the session layers, which is the 5th layers of the OZ model, which contain the session management. The 6th layer is presentation layer, which contain the extensions of all the things related to the web, like WMV and GPG and Move and etc. and so on and so forth. And the 7th layer is the application layer, which contains HTTP and the SMTP. To remember the OZ model, you can remember this sentence: please do not throw sauce pizza away. Repeat after me: please do not throw sauce pizza away. Every first letter of this sentence present the layers of the OZ model. Now we move to the IP addresses. We talk a little bit about some binary lessons here. If we type ifconfig on our terminal on kernel Unix, for example this, if I type ifconfig, I will get an IP addresses which is called inet, which contain full of 4 numbers, contains 4 numbers separated with points: 192, 168, 44, 130. And I have also inet 6, which contains also a 4th number, but and at this time it contains hexadecimal numbers, not IP addresses. Okay. Now we'll back to our keep noting. The IP address is in fact in the layer 3 of the OZ model. Contains 4x of numbers, and 2 types of IP addresses are the decimal and the hexadecimal. The decimal IP addresses is the IPv4 decimal, and the IPv6 hexadecimal. They exist, both of them, on the layer 3 of the OZ model, as we said before. Every and each component of the IP addresses contains 8 bit. When we, in our example of IPv4, we have 32 bytes. When we make some calculation with mathematic functionality, we can get 2 exponent 32. We can get 4 billion addresses. Okay. And now, when we divide the number of 255 bits, we can get 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. We can get 255 bits. In front of each number here, we put 1. If we put 0 here, we will get 255 minus 128. We'll get 127. If we back it again to 1, we will get 255. This is in fact the machine language. The machine language, or the routers, or the devices, are not dealing with our language, are dealing with 1 and 0, always. Now we'll make some examples to explain it more and more. If we have 7, 7, 7, 7, as an IP address for repeated 4 times, we'll have 000000111, which means 1 plus 2 plus 4 equal to 7. Is it clear? I hope that it is clear for you. It is very important, these lessons, to you and your career, as anything can happen. Now we will move to the IPv6. The same protocols of IP and bits and bytes are maintained on the same IPv6. Now, if we make some calculation, 2 exponent 64 bytes, we can get almost an infinite number of hosts and networks. So we do not have to calculate it. Okay. Now we will move to MAC addresses. MAC addresses is on the layer 2, which is on the physical address. It is on Ether of the Kali Linux machine. I will show you my MAC address. If I type ifconfig, the MAC address is this number, is this pool of numbers. It is not important to know it by your heart now, but it is important to know that the MAC address is on the layer 2. Remember this, and it is always good to remember this information. Now I will leave you make some notes, rewatch this video, make some advancement, and the next lesson will be on the TCP, UDP, and the 3-way handshake. Okay, see you later, and bye bye.